Howdy everybody. In this video we're going to do a repair on a NanoVNA. It's my personal NanoVNA. This is the SAA-2N, and the problem with it right now is one of the ports have blown out. I'm hearing on the interwebs that ESD can damage one or both ports depending. Sometimes it's just static that's built up on the coax cable, and you go to plug it in and yep, goodbye NanoVNA. So we're going to dive into this right now. I have it on the bench. All right. So what we're showing you here is my SA2NN. We got is the has the two N ports on it. This is the back side of it. And what you'll find when you've blown the ports is even after you've done a cal, I have my whole cal kit right here that comes with the unit. So you have the open, short, load. Once you've gone through the cal, you get squiggly lines everywhere and really crazy SWR or S11. It just is all over the place. So what we're going to do is we're going to take this apart. There's the nuts for the the nuts for the end connectors, and there's about 4 or 5 Phillips head screws. Yeah, we're going to go and take it apart now. Okay, once you get the backing plate off by removing the nuts that held on the end connectors, and a total of 6 screws, the unit should just slide out like this. Gently slide it out. And put the case aside. Board that we're interested in is this top one. So let me get this top one off and we'll be right back. Okay, here we are looking at the chip that went bad. It's the U551 from Maxscend, model MXD8641. It's a 4 input, 1 output RF switch. And the CPU, the microprocessor, controls this thing, and it's attached directly to the SMA port here. So this chip during calibration is used to make the connections between port 1 and port 2 and back and forth. And so what we're going to end up having to do is repair this chip. We're going to take it off the board, desolder it, and we're going to solder it back on. So I have a few of these on order already, so we're going to take care of the soldering, and we'll be right back. All right, we got the unit back. We're going to now set it on the bench here and do a little first cal on it. Let's see what happens. Got a couple antennas here that I want to try out. It's like a little small. I don't even know if this is a 2.4 or maybe 2 meter or 440 antenna. I think this probably was maybe like a 2.4 antenna. Oh, PC board Yagi antenna. So let's turn it on, make sure it still works. Okay, I think we got a working display. I'm going to change the stimulus here so we can cover these antennas. Let's start at 50 megahertz. Okay, that's good. And then why don't we stop at 2.5 gig. I kind of think these antennas At least this one right here, the PC board antenna, I think goes up to 2.4, 2.5. All right, so we have our cal kit here. So let's bring out, we got the open. There's your open. There's the short. Yep. And the load. Focus. There you go. All right, and I even have the through cable that came with the unit. It's just end connectors on both sides, a little short cable. So we'll do that too. So let's start the cal. Go back. Let's go to calibrate. Let's go calibrate again. Let's apply the open. And do that real quick. There goes an open. Okay, and we'll click. All right. So it took that value. And then we'll go to the short. Let's see if I can get this to a point where you guys can watch. Maybe like that. So short. Here's the short. We're doing the short. And short is good. And we're going to do the load. The load on. Look at that. Load is good, and everything's starting to look correct. Okay, and then this last one is isolation. It just says ISOLN. I don't know if you can read that at all. There you go, ISOLN, isolation. And that's usually just the two ports wide open, or if you have leads, the two leads, or two coaxes wide open. So we'll just do that real quick. And that's good. And now we can do through, which would be this cable connected between the ports. So let's do that. That one there. This one there. It's starting to look normal to me. Looks like the unit's actually functioning. All right, so we'll click through. Oh, you can see that. Of course. There we go. Through. That's this one. Yep, and then we'll click done. And then we'll save it. Well, let's save it into 4. All right, so this says C4. That means it's using calibration set 4, which is the one that we just saved. So, oof. Some of these are hard to get off. Oof. There we go. All right, so we're back to a semi-functional, semi-normal NanoVNA. So let's try one of these antennas. We can do the PC board antenna first, since it's already been mated with a SMA to N type connector. We'll connect that up. Oof. Wow, these N connectors are. Yeah. Okay, so I'm seeing some results. Let's take off some of these other displays. So we'll go display, trace. Let's take off the Smith chart, that's the green one. Let's take off phase, that's the purple one. So that is leaving us with the yellow trace, which is S11, and the light blue trace, which is S21. So what we can do here now is we can slide the marker down and see what this Yagi is doing. Look, the marker's right there. I'm seeing 2.3. You guys seeing the same thing? This Yagi's actually kind of not too bad at 2.3. It was intended for Wi-Fi, so it's a little low. It should be around 2.4, but it's actually looks like it's resonant at 2.3. Anyway, I'll call that good. Good test. We're gonna remove this guy as soon as it comes off. Oof. Wow. This end connectors on the Nano SMA or NanoVNA, they're really finicky. They need to be broken in, I think. Not broken, just broken in. All right. So this time we're going to do this little width. That's maybe, what is it? 1, 2, 3, 4, 5, 6 inches long. About 6 inches long. We'll see what kind of antenna it is. Not really too sure. Okay, got an odd fellow here. It's resonant in at least 3 different places. 2.2 gigahertz. Then we go all the way down. 1.8 gigahertz or 1700, 1800 megahertz. And it's also resonant down here at 400. So very weird antenna. Totally weird antenna. Let's just make sure not my body influencing the readings here. I hope you guys can read that. There you go. Yeah. So I will call that legit as well. Looked like a good reading anyway. Take it off. All right, I would call that success. Got a working unit again after replacing the IC. So I hope you guys enjoyed that. It was pretty fun on this end, trying to figure out what was wrong with my blown up NanoVNA. But we got it repaired. It seems to be working okay. And so hopefully many more years of usage out of that unit. So I put some links below. Check them out. The original blog post that I found some instructions about doing this kind of a repair. And the site where I got the IC chip, the RF IC chip, the 4-way switch, and it's really small. So yeah, you might want to take it to somebody who can actually do it if they have the right desoldering tools. Hot air is the only way you're going to do this. There's no way of doing it with a soldering iron. The surface mount chip is really small. Anyway, take it easy, and 73.